Hello, Silverliners, and welcome to our Multi-Cloud Summit. I'm Liz Coyne, Managing Editor here at Silver Linings and your host for today's event. Before we get started, I want to thank our sponsors for the summit. Prosimo is our platinum sponsor. Gold sponsors are Red Hat and VULTR, and silver sponsors are Aviatrix, F5, and Rakuten Symphony. Also, some housekeeping items. If you have any issues with your browser today, simply refresh and that should fix everything. We've got Q&A box on the top left-hand side of your screen if you're having any issues or want to send in questions to our speakers. And all sessions will be available on demand. Also, you can join the conversation on our social media channels. We have hashtag Multi-Cloud Summit for today, and we're on LinkedIn at Silverlinings Info and Twitter at Go Silverlinings. All right, let's talk about today's session one. This session is called Multi-Cloud State of the Industry, and it kicks off with a fireside chat with Matt Ferrari from Wayfair. Then we're going to move into a partner keynote from Prosimo. And then we have a panel hosted by Mauricio Sanchez from Dell'Oro. Then we've got another partner keynote from VULTR and a closing keynote from Vodafone. So it's going to be a really exciting morning, and I'm going to hand it over now to Matt and Diana for their fireside chat.
Thank you for joining us at the Multi-Cloud Summit. We are here with Matt Ferrari, who is head of enterprise and platforms at Wayfair. Matt, thank you so much for being here today.
My pleasure.
Right into our questions. You and I have discussed it previously, but Wayfair recently undertook a massive move to the cloud. So I'm wondering, just for our audience, can you provide a brief overview of the project? Why did Wayfair decide to move? And how many apps are you actually moving?
Yeah, of course, Diana. So grateful to be here and to speak to all of you. So the story about a 20-year-old company that has built roughly 6,000 of its own applications. Picture everything from back office apps to the way we talk to suppliers, to the way that we actually talk to customers, and everything in between. So Wayfair grew up as a company that built all of its own IP. And so to answer the question, came to a crossroads as we thought about how to differentiate in the space. And the space that we're in, of course, is kind of that e-commerce, retail, home business. And if we're going to differentiate, should we be differentiating in core infrastructure, in network switches, scalability, things like that? And the answer overwhelmingly is no. That's not why a customer talks to Wayfair. And then we thought, well, okay, we have 20 years of all of this infrastructure knowledge. Should we differentiate in the areas of scalability? And the answer was overwhelmingly no. E-commerce and retail is exceedingly a very seasonal business, right? We think about peak days in Wayfair's world. That's things like Way Day, where big sales events, or maybe that's Cyber 5, when everyone's buying presents for the holidays. And so the truth is that we didn't want to continue to maintain infrastructure for spiky seasons. So we thought about scalability. And then the third one, which I'm sure we're going to talk about, is reliability. How can we make sure that we have things like 5 nines for some of our applications that can't go down? And so transparently, Diana, that's why we made the journey to the public cloud, was really thinking about scalability, reliability, and differentiation.
Okay, so let's talk a little bit about what clouds you chose and why. Is this a multi-cloud endeavor? Is it a single cloud endeavor?
Sure. The vast majority of Wayfair's applications are on Google Cloud. So probably important to know, Wayfair is completely out of the on-prem data centers at this point. That was a journey in itself. And the vast majority of it is now inside of Google Cloud. There is a subset that is also within Microsoft Azure. We think about public cloud as based off of individual use cases. So we have a deep partnership with Google. We've had one for years. If you think about, again, kind of that retail e-commerce space, clearly there's going to be some synergy as it relates to things like how to market to a customer, or Google AdWords as 2 examples. And so there's synergy there. And then we are very much a heavy adopter of machine learning and data science at Wayfair, very focused on making decisions based off of data as it relates to our customer journey and our supplier journey. And so Google was a great choice for us from a partnership there. From a Microsoft perspective, we're partnered with Azure on some of our back office. A lot of Wayfair's history has been in kind of the .NET Microsoft SQL world. And while that's a journey moving into more cloud native data, more cloud native decoupled databases, there is some legacy there as well. So that's kind of the split today.
Okay. So can you tell me a little bit about the transition process, before we dig into the things you mentioned earlier, reliability, security, tell me about the transition process. So did you refactor your apps to be cloud native first, or are you doing that now? And what was the reasoning behind which order you did that in?
It's a great question. So the shortest answer is that for the vast majority of those 6,000 apps, they were lifted and shifted. And now they're being refactored. When we talk about refactoring, everyone has different terminology. Just so you hear it from a Wayfair perspective, that's a focus on data decoupling. So how do we make sure that data is decoupled from, let's say, a monolith or a giant database, or in this case, a SQL server or a series of SQL servers, so that the data queries have a single purpose, right? You often hear them as SPDBs or single purpose databases. And then code decoupling, right? How can we make sure that legacy code now is written in such a way that it also has a single purpose, so that when we make a code change, we don't have to think about the 17 things that it impacts downstream. And so a lot of that stuff is what's been going on now. But step one, to answer your question, was let's get it into public cloud. So a lot of that was the network design and network topology architecture. A lot of that was the how, right? How do you move things like VMware virtual machines or physical dedicated machines, if you're kind of old school data center, into, in Google world, what is known as GCE, or Google Compute Engine, and later Kubernetes. And so the way Wayfair thought about it was, let's get everything into the public cloud, then let's start refactoring. Now, along the way, I would tell you that many of the applications didn't actually get lifted and shifted. It was easier for us to rewrite them. So there were, let's say, a small percentage, Diana, that were refactored while in flight because the juice wasn't worth the squeeze as it related to the transformation.
Okay, so let's talk for a quick second about those other things that you mentioned. Security, reliability. What does the cloud bring to the table on those fronts?
Sure. So we think about reliability first off. When I think about reliability within public cloud, you're thinking about the ability to have some kind of node. Maybe that's a physical node. Maybe that's a network device. Maybe that's a firewall, and have no hit to reliability. In the world of public cloud, oftentimes that means that you are setting up multiple availability zones, so that you can actually have kind of a fault tolerance model and lose, depending on the application, lose an entire site or lose an entire public cloud data center without impact to the application. In Wayfair's world, not that many apps need that kind of redundancy and reliability. Maybe like the things that you see as a customer, like the website or a process of an order, certainly do. But it really depends on the tier of application. So when I think about reliability, I also think about, let me tailor the needs, or how many nines do I need from an availability perspective, based off of how important the application is. And so that has been something that has been really strong from a public cloud perspective. On the security front, we think about both the third party and cloud native security technology that we use within our stack. And so some of it might be cloud native, things like intrusion detection or intrusion prevention or DDoS prevention, all things that most public clouds have native inside of their architectures. And then you think about some of the third-party things you might need. Maybe that is very specific web application firewalls. Maybe that is third-party vulnerability scanning or penetration testing. And so Wayfair takes a combination of leveraging third-party, let's say cloud partners, and native public cloud technologies to really provide kind of a robust, secure solution. And then we build all of that into our architecture or our design, so that, to your previous question, when we go back and we design an application for a transformation or a change into cloud native technology, we have security already embedded into the model. So we already know what are we doing for all the things that I just mentioned.
What was the biggest challenge that you faced in your cloud migration journey? Or, what do you wish you'd known before you got started?
Sure. In terms of the challenges that we faced in the cloud migration journey, the largest one by far is how difficult it is to actually to unwind the past. Just because you are lifting and shifting an application, you're still running it as a data center until you transform it. So sure, it's not your hardware. Maybe it's not your network anymore. It might not even be your IPs. But the truth is that if you lift it and shift it, you're still, let's say, running a Linux VM or a Windows VM. You're still running a SQL server. You're still dealing with access control and identity and access management. And so one of the key lessons learned for Wayfair was very much focused on how can we then accelerate using the cloud for the cloud? How do we accelerate actually using the public cloud for the use cases that it provides? And use cases it provides, again, for Wayfair, were around scalability. How fast can we scale during seasonality? For some of that, you have to rewrite the application. It really around reliability. How can we use all the cloud native reliability technology beyond just compute to get our job done? And then really focusing around redundancy and security. So I would say, TLDR there, Diana, the lesson learned for Wayfair is very clearly how fast can we get to a decoupled world where we're actually using the cloud natively.
Okay, so one of the other things that I wanted to touch on is you mentioned that you're using two different clouds. Do you have any sort of tool that you use to manage across both of those, or are your apps mostly in one cloud or the other?
The vast majority of apps are inside of GCP or Google Cloud Platform today. There is no aggregate or single pane of glass between the public clouds today. Wayfair built its own internal API, if you will, that allows us to provide our software developers, and we've got thousands of software developers, native cloud access to things like Google Cloud so that they can provision resources, and it'll automatically do things like add all those security tools that we talked about, or create a secure Terraform template to make sure that we're provisioning a hardened environment, or make sure that those assets are tagged to make sure that we understand what monitoring needs to be set up and what SLAs need to be set up. So Wayfair kind of built our own shim, if you will, on top of public cloud so that it serves a purpose directly for Wayfair. But other than that, there is no single pane of glass across the two.
Okay. So I have another question, and you and I had chatted about this a little bit before. Now that Wayfair's in the cloud, what kind of impact does that have on your developers and engineers in terms of their day-to-day life, and their day-to-day focus?
Sure. So while I just mentioned that we had to build some tooling around public cloud to make it more purpose-built for Wayfair, the short story is that there's no more like ITIL, or if you're familiar with frameworks around change requests, right? Historically, you would treat resources, whether they're public or private cloud, as requests, right? Hey, I need a new server. Hey, I need a new switch. Wow, we're out of storage. That kind of stuff. What traditional Fortune 500 companies have to deal with every day. With public cloud, we now focus more on empowerment and enablement. How do we give you direct access to Google services or Microsoft services so that you can provision your own assets? And it comes back and you own the dollars, you own the budget, right? So there's kind of like a chargeback model or an accountability model, if you will. But it removes the request piece. So it removed the need for like a department that provisions servers and storage and switches and all that kind of stuff. we now leverage the public cloud directly for that, right? So we were able to shift a lot of the wait time into software development time. We measure that using DORA metrics, or the ability to actually determine how fast are we ultimately developing software. In most cases, DORA metrics are focusing on things like mean time to resolve an issue, deployment frequency, how fast can I deploy software, and change failure rate. So we've seen an improvement in all of those key areas as kind of a proof point of public cloud.
Okay, so my last question for you in the couple of seconds that we have remaining is, what advice would you give to another large enterprise who is preparing to move to the cloud?
Sure. I've been fortunate enough to do this a couple times within different organizations, been in the public cloud for a long time now. I would say that the piece of advice is, first, make sure you have a full inventory of the applications that are going to need transformation. It is highly plausible that you are thinking about it in bigger terms, in terms of total storage or total VMs, things like that. That's important, but you need to understand what services in the public cloud you're going to use when you get to the other end, right? It's not all just going to be compute, or you're doing it wrong, flat out. And then the second thing, the second piece of advice, if I could add a second one, is really understand how this maps to your cost. Tons of different tools out there, both third-party and cloud native, that will help you with this. But doing a full TCO to understand what is your total cost when you actually get to phase one, maybe that's lift and shift, or maybe when you get to halfway through a transformation. And by the way, that's not all public cloud services and compute. A lot of it's licenses, right? Maybe when you move to public cloud, you're doing things like getting off of Windows Server or getting off of Microsoft SQL, as two examples. And so you want to do a TCO of the environment as well, because otherwise cloud can be a challenge from a financial perspective if you don't have that full kind of transformative step function thought around how are you going to step function into the public cloud in a financially responsible way.
Excellent. Well, Matt, I think that's all the time we have for today. Thank you so much for sharing all of that information with us. We really appreciate you being here.
Yeah, of course. Thank you, Diana.
Thanks so much, Matt and Diana, for that excellent fireside chat. And now over to you, Manny, for your keynote.
Hi, welcome everyone. My name is Mani Ganesan. I head the product management team for Prosimo, the multi-cloud networking software company. In today's keynote, I'm going to be covering the top multi-cloud networking challenges faced by enterprises. I'll be touching upon different trends that's driving the need for this market, and I'll be going through different challenges. I'm going to take a real customer example and walk through their journey when they worked with Prosimo. First thing, what are the top drivers? The reality of enterprises today is where the applications are moving to multiple regions, at least in a single cloud, or it's multiple cloud. So it could be, the reason could be agility. They really want to leverage different types of cloud native services. It could be PaaS services, cloud native databases, some AI services coming from GCP and so on. It might be different reasons why the application developers might pick and choose different cloud providers. And as a networking team, they have to stitch together all these services and make sure that the performance and the security and the connectivity is all top-notch for enterprise applications. And some customers have tried to do this with different MCN vendors, multi-cloud networking vendors that developed the solution 5, 6, 8 years ago. And the model was to drop a couple of virtual appliances in every VPC. That was okay before the cloud native services themselves were launched, name it a transit gateway, virtual WAN from Azure, cloud WAN, and so on. But today, dropping the data center model of virtual appliances in every VPC just doesn't work. So customers are struggling and looking for a better option. The third biggest trend is the app diversity. I touched upon the reason why customers are even moving to multiple clouds, the primary reason. But then when networking team comes in, they're grappling with different application endpoints that need to talk to each other. It could be lift and shift applications running on EC2 instances and different virtual machines. It could be some modern applications, serverless applications, Lambda functions, and so on. and some of the microservices applications as well. It could be service mesh, Kubernetes. When these are different types of endpoints, including the PaaS apps I touched on, when they all have to talk to each other, there is no one size fits all here. You really cannot drop in an IPsec tunnel and some BGP router and say, now you have to talk to each other, right? This really requires an understanding of cloud native applications and the ability to understand work at layer 7 and stitch them together, right? That is a primary reason why the modern multi-cloud networking needs are coming out. Lastly, the net DevOps mindset. It used to be the case where at the max, it was all about automation. It's still virtual appliances, but you can automate with some scripts and Python and Terraform and so on. Now, customers really want their infrastructure, the networking infrastructure, to be matched up with the application stack. It could be based on the same GitOps framework, CI/CD stack, where you launch an application in a particular VPC in a region. All the infrastructure related items, it could be the connectivity, the security policies, and everything should come along with it. That way, there is no need for a separate team to come in later and patch up the networking requirements, right? So it's true net DevOps mindset is becoming a reality as well. And you cannot forget cost, last but not the least, but the most important part, right? Where this is an example, I saw this and then I was just kind of laughing to myself because this is the true challenge customers are facing. It's a single GB of data. Just an AWS example, it applies for all the other public clouds as well, flowing through different networking services, multiple types of load balancers, a CloudFront, a transit gateway, a NAT gateway, you name it. And every single time, our AWS managed firewall, the same GB is getting tolled at multiple places. And when you pay tolls for so many times, they all add up, right? And what we are seeing here is enterprises on average pay 17% just for networking services in the cloud, right? That's a lot. If you're a large enterprise and your cloud bill is 8-figure, in some cases 9 figures, and this adds up quite a bit, right? You really have to be cognizant of what your cloud networking charges are and find ways to optimize it. And multi-cloud networking stack is getting deployed to get this back in control as well. So these are the top trends that are driving the need. If you're brand new to multi-cloud networking, you're trying to understand, hey, what is this market? What is driving up the need? You should be aware of all these trends. Now, I'm going to use a new term called full stack cloud networking, right? I'm going to take a customer example. Hey, what is full stack? Full stack, that are used in different ways, and it used to be referred to as developers that can work from the UI layer all the way up to the backend, right? These are different terms. We use full stack cloud networking with a particular use case, right? I'm going to use a customer example here. This customer, of course, like any other enterprise, they started off their cloud connectivity journey with simple things like, I have a bunch of VPCs on top, I need to connect with each other. So they turned on some cloud native service, could be Transit Gateway, Azure vWAN, you name it. And the next step, you see one more layer below. Now, the advanced use cases came up. Now, they are running into overlapping IP addresses. By compliance requirements, they have to segment the network in a certain way. And then they also needed to have a firewall in the path when these two VPCs talk to each other. Then came the requirement of this VPC, it has to go talk out to anything in the internet. They need to have strict egress control, or what are those applications out in the wild internet that these VPCs are talking to, right? It could be for valid reasons, like pulling up software upgrades, patches, and so on, but it has to be verified and controlled in a very strict fashion. And multiple accounts, right? These VPCs might be talking to other services that are owned by different teams. How do I manage all these things, right? So what started as a simple cloud connectivity problem between two VPCs in a single region now ballooned up to this complex problem. Then came kind of the next dimension of complexity, which is multiple regions. The same cloud provider now for maybe geo-redundancy reasons, and they're saying that, oh, I'm kind of all in on the East Coast. Let me actually go deploy the same applications in the West Coast. This is becoming a multi-region problem. Then came another business unit, or they acquire a company. Now they're saying, I'm using a completely different cloud provider. It's the cloud networking team's job to kind of mesh all these together, right? Now it's becoming a multi-cloud problem, and you're figuring out how do I connect them all the way from the underlay. Should I go work with an Equinix and Megaports and so on to get those circuits underlay connectivity? So this is truly, even at layer 3 connectivity, this has become a complex problem. Now add on all the application requirements are talked about. So that might be a TCP application at layer 4. And now you're looking at, oh, should I drop a private link endpoint into the VPC so I can consume that application? Or it could be a layer 7 application, modern API-driven applications. And it might be a patchwork of different proxies and ALBs to ensure that the endpoints from certain VPCs are talking to endpoints in another VPC. Before you understand now, really look at layer 3, layer 4, layer 7, it is becoming a very complex problem for an enterprise. This is a journey that we see over and over again. Enterprises underestimate, hey, networking, it's just make two VPCs talk. I've done this all my life, IP layer connectivity. Now, this is very different. So that is where the need for full stack has come in. At Prosimo, we've been using this term for a while, where if you put in this networking stack in the middle, that works the same way across any cloud provider, any region, and it can optimize all the way from you're attaching whether layer 3 subnets or FQDNs and PaaS services, it's exactly the same way. And you're able to actually solve this for any cloud and any direction, whether it's region to region, cloud talking outbound to internet or inbound traffic control, any direction of traffic patterns you should be able to control. And all these should be delivered as a service, right? Doesn't mean that you need to have a middle mile provider. I'm not talking about you route the traffic from VPC to yet another cloud in the middle. Rather, the stack should run in your own cloud, but you should not be worrying about how do I kind of patch the software for this new stack I'm managing, who's going to kind of maintain the uptime for this, high availability, scaling, all those management challenges should be completely gone. It should be the vendor's responsibility to deliver this as a service with a high SLA and availability and everything. And it should be optimized for developer velocity. I'll touch on it at the end, right? The reason why you're putting the stack in the place so that your developers could move fast. And they don't want to open a ticket and wait around for somebody else to come patch up the firewall rules and networking and so on, right? It has to be. So this is a common set of asks we see from enterprise customers over and over again. Simplify the stack for me. I don't want kind of the soup of multiple different appliances managing all this. Can you simplify this? With that background, I'm going to kind of touch upon how Prosimo solves this, right? So we've been working with large enterprises solving this problem for a while now, right? We are a 4-year-old startup. So our journey goes like this. It starts with discovery. Our stack is built in a way that it starts with brownfield discovery of everything. I'll touch upon each step in a second, but I want to kind of walk through the journey. Discovery of existing resources. Once you have discovered that brownfield existing resources, you can build a policy around it. When I say policy, it's connectivity policy. Who should talk to who and how they should talk. Should they use existing transit gateway or should they integrate with an existing cloud WAN, virtual WAN service, Google Cloud Interconnect, you name it. You should be able to do all of that. And depending on layer 3, layer 4, layer 7, you're able to build all of that. If you run into challenges like overlapping IP addresses, a business smarter coming in, how do I ensure connectivity still works? The build step should automatically take care of all that using abstractions. Then comes security. It could be for segmentation reasons, inserting a firewall in the path, making sure only the right set of resources are talking to each other. Then comes observability. You're kind of handing this off to a DevOps team, net DevOps team, and they should have a simple tool to figure out if something breaks or even proactively understand, is everything working well? Is it an infrastructure layer problem or is it a cloud native problem? Where exactly is the problem coming from? And can I trace the path end to end? And all those are observability challenges. And we'll touch upon that as well. This is this 4-step process. We're able to replicate this with several customers and get them to a much more modern state. It's a simple case, how the stack looks like, right? You can see multiple regions, multiple clouds. When Prosimo comes in, it kind of becomes a network plus service layer stack. There's a network layer connectivity and a service layer connectivity, which is an application layer. And once you drop in the Prosimo gateways, you're able to build this mesh network across clouds and across regions, which is layer 3 aware and layer 7 aware. And you're able to kind of terminate the remote users through zero trust control with that. And you're able to kind of attach your existing fabrics. It could be SD-WAN fabric. It could be at the data center fabric. You're able to simply attach to this cloud fabric you're building. That way there's existing model that's completely extended to the cloud as well. So I'm going to, in the next couple of minutes, double click on some of the key challenges and so show samples of what that looks like. Discovery, within a couple of minutes, you are able to kind of discover all the existing resources, right? As a cloud platform team, doesn't matter what the developers are doing, you are able to quickly figure out these are the regions, these are the VPCs, these are the subnets, these are my applications. Can I get a full view of what they are, how they are connected today, even before I drop anything from Prosimo software, right? This is the first layer of value we provide. Then you build, kind of operationalize and rationalize all of these using connectivity model. One key distinction with Prosimo is we will not ask customers to rip and replace their existing cloud native connectivity. We kind of make the existing connectivity work along with Prosimo stack, right? Transit gateway, virtual WAN, private links, Google PSC, private service connectivity, peering, you name it. Customers always have a combination of all this. You'll be able to build all of them and solve for some advanced challenges like overlapping and so on. Once you build it, then comes the segmentation and granular access control. All of the security needs are built into the stack, right? What type of policies you want, what type of filtering you want between VPCs and regions. Do you have GDPR compliances you have to maintain? Do you have PCI, HIPAA, you name it? You'll be able to map them out into kind of policy layers in Prosimo, right? Meaning VRF-like segmentation, protection, staging, and all those things, right? And lastly, firewall insertion is so easy. A couple of clicks, leveraging native services like Gateway Load Balancer will make it easy for you as well. Observability and troubleshooting, the most popular tool we have, it's called a Cloud Tracer. You see a simple sample of that where end-to-end from source to destination across all the services like the subnet route table, transit gateway, VPC route table, security group ACL, the Prosimo policies, Prosimo connectivity, all the way across from Azure or GCP. You'll be able to see all of these with a few clicks, understand top talkers, understand all the reasons why a traffic flow might be dropped as well. It's very, very key to troubleshoot issues much faster in the cloud world. Cost, I touched upon how important it is when your cloud bill could have 17% attributed to networking, how well you can understand this, right? Which account is running up the cost, which cloud, which region. Can I attribute this back into a particular application owner, and can I charge them back? If you have a chargeback model where you own all of the common services, like all the native services and multi-cloud networking stack and firewall management and whatnot, you want to attribute this exactly into application owner, you will be able to do that as well. And lastly, optimizing. And Prosimo provides easy way of optimizing which path this traffic should be taking between cloud backbone and some private backbone you may have using Equinix and Megaport and your favorite telcos. You really want to leverage that path in a simple policy-based manner, you should be able to do that as well. And you get full control of how you route the traffic, how much visibility you have on the cost. Lastly, developer velocity. Talked about the entire reason you build the stack is about providing the velocity to developers. If I'm writing apps on Azure and some other developers are writing on AWS, in large enterprise, you might be starting to use GCP now. When this becomes a reality, this mesh that you build, which is agnostic of cloud, agnostic of underlays, you'll be able to simply attach them at any layer 3, layer 4, layer 7. As a developer, I can go to a self-service portal, provide my application requirements, and automatically it becomes real, right? I should be able to make my application available to all the other services that it needs to talk to, and all the other services it needs to consume the application service as well, without ever going out of compliance. Talked about all these, repository of all the services, all based on FQD and routing. It is not your age-old IP routing alone. It has an application layer stack built in that. Lastly, call to action. You'll be able to drive home these outcomes for your enterprise. If you're a cloud network architect, cloud platform engineer, or an executive in charge for these outcomes, like accelerating cloud migration for your enterprise, maintaining security and compliance, or you are an enterprise that buys a company a lot, M&A, how do I modernize my application stack without ever having to worry about all the challenges of overlapping IPs and so on? If you have any of the challenges, B2B connectivity comes up a lot, right? Business partners connecting into your core applications in the cloud. You'll be able to unlock these business initiatives in a much robust way with a solution like Prosimo. If you think this was of interest, you really learned something, you really want to get a hands-on experience of this, just go to prosimo.io/CNS. We provide instructor-led labs for you. We'll build out a custom lab for you. And within a couple of hours, you'll be able to see all this in action as well. And really appreciate you joining. Thank you, and look forward to working with you.
Thanks so much, Manny, for that excellent keynote. And now over to you, Mauricio, for your panel.
Thanks a lot. Good morning, good afternoon, or good evening, the case may be. This is a live event for those tuning in as we speak. And today I've got a distinguished set of panelists with a set of topics to be able to hopefully complement what we just heard from both Matt and Manny about the topic of multi-cloud and what it may mean to you as you embark on this journey. So a couple of housekeeping things. There is a Q&A capability to the platform. Please submit, because I want to make this interactive. And I will try to weave them into the set topics that we have the time allotted. So I know that some of you probably have top of mind questions, so let's make sure that we tease them in or bring them into the conversation. By way of introduction, my name is again Mauricio, and I'm an industry analyst at the Dell'Oro Group, a quantitative market research firm based out of North California. And I cover enterprise security networking, and I am leading the practice in terms of what does it mean to the enterprise as they embrace the cloud. And so hence why I got tapped on the shoulder to come in and help steer this conversation. But together with me today are three people with probably way more experience than I have in terms of this topic. And so I want to give the opportunity to each of them to introduce themselves and give a little bit about grounding about their background, and that way be able to establish kind of the key expertise that we have in this panel today. I'll start with you, Beth. Why don't you introduce yourself, give us a little bit about your background.
Sure. So currently I am a product manager with Verizon, working on network solutions or complex network solutions, including multi-cloud. Launched several multi-cloud products, including Secure Cloud Air Connect. But my background goes much further back in cloud connectivity and just in clouds in general. So I actually worked back in the day for both Brennick and Newman, which was one of the pioneers in developing cloud services. We had one of the first web server farms, for example. The rest is history.
Thank you, Beth. Definitely been seeing a lot in this journey of clouds. Rahul, on to you. Give us a little bit about your background. Rahul, you hear us?
Yeah, hi. Thank you for having me. I'm working with Appledore right now as consulting analyst. My portfolio includes distributed cloud and everything under and over distributed cloud, including orchestration, multi-cloud strategies, monitoring, lifecycle, and a lot more, which the organizations and enterprises can get out of cloud. The background also includes product management as well. I worked for world's first cloud native network, including Open RAN. Used to head all their products, automation and lifecycle management. I've worked through all my life in organizations where we have been on the forefront of technology, but also look towards creating products and portfolios around the same. Cloud happens to be one of the most special things in last 5 years of my career, and really looking forward to talking to each one of you and discussing more.
Thanks, Rahul. Well, last but not least, Jyoti, give us a little bit about your background.
Sure thing. Pleasure to be here. Thank you for having me. I'm Senior Director of Product Management here at Prosimo. Deal with all aspects of product management, building the product, building sort of an innovative offering, trying to solve, build with Legos in the cloud, like I call it, right? With the constructs that the various CSPs have. The most fun part of my job, obviously, is doing and uncovering the challenges that these customers have, with their multi-cloud environment, trying to solve them. Background-wise, I'm going to date myself here, all the way, to the things of sort of the data center with storage and networking switches. I started at Cisco. Spent about close to 20 years there, watching the evolution of the industry, having a front row seat at seeing how, customers, faced with the challenges of, hey, today, I'm running a massive data center, and all I'm worried about is, sort of reliability and scale there. And then suddenly the public cloud explosion happens, and refactoring, what was initially a problem from sort of on-premise data centers to the cloud has now become a cross-cloud problem, right? One day I'm a single cloud and tomorrow I'm multi-cloud, right? By virtue of an acquisition, by virtue of a simple AI workload that's running there. So it's interesting. It's fascinating. I think ISVs like Prosimo have a disruptive role to sort of play here to enable some very key use cases for our customers. So very excited to be on this panel and share my thoughts here.
Thanks for that. There's no need to be shy about dating ourselves, right? I call that wisdom, right? It's like that's what we bring to the panel today, between the in the trench experience that you'll bring to the table. So let's start with the first topic, and let's start with you, Rahul. The question is, now, what does multi-cloud mean to you, and what do you think the key challenges is? And you can compare and contrast between what Matt or Mani said, or just give it from the perspective of the in-trenches experience that you clearly have.
So I think this has multiple answers, to be very honest. And I always believe that when you look into a solution or a problem, you have to look into people, process, and technology altogether. So from technology perspective, multi-cloud to me have different avatars to be distributed, to be available for the application which are closer to the customer, closer to the internet peering point, and also think about the control plane, user plane, kind of aspects of the cloud. But overall, what we want to figure out is the universal infrastructure layer, which can provide you about the reliabilities and capabilities to host multiple applications. But all of these changes when you move to closer to the users or move farther away from the users, and then depends what kind of ROI TCO model you want to have, what kind of KPIs, SLA, success factors you want to capture. For example, at the edge, closer to the devices or users, you are thinking about the jitter and latency and the actual experience. When you think about regional edges, or you think about the central data centers like we were talking about, you think about the reliability and scaling power of the capabilities the infrastructure bring in. The processes part, I think it also gives you a possibility where you as an organization can grow from hosting, let's say, bare metal or servers upfront, maybe over dimensioning at point, but at this point of time, you can actually become a little more digital. You can think about on the fly. You can think about use cases which you can dynamically solve. You can think about runtime. And you can think about all the possibilities of CI/CD deployments, sandbox, and also taking the snapshots out, thinking about applications which are across, which are not that seamless in terms of the spikes they require the infrastructure on. On the people process, I think it's a wonderful opportunity for the organization to grow, to become open, transparent, and think about how, as an organization, they can become common solutions, common knowledge, common infrastructure, universal layers of orchestration, universal layers of lifecycle management. You can simplify operations a lot. Probably there'll be a curve, sinusoidal, to say, yeah, you'll have complexities and challenges and days where troubleshooting becomes mess, because you have to have vertical layers across infrastructure, cloud, and application and services. But eventually you cut across all these three layers. You can think about strategies where the strategy is build versus buy versus what kind of ecosystem partners you have. Organizations who love to challenge themselves, who want to be agile, goes generally for building their own clouds, building their own infrastructure layers. Organization which works on applications which require scalability on the fly, like AI applications and lots of processing, goes for multi-cloud. There are multiple application regulations across application which also figure out people to take hybrid approaches. So all this together, strategy, people, process, technology, for me is the real meaning of cloud and things on the infrastructure side.
Well, thanks for that expansive answer. You touched on a number of different things, from process, people, and technology. Now, when I look to either you, Beth, or Navjoti,
Yeah.
how do you compare and contrast what Rahul said versus how you see things?
Yeah, so I want to set in. I mean, obviously, I'm talking from a networking perspective, though that has not always been my main focus. I did run cloud services, but that the thing with multi-cloud is that Raul is absolutely right. It adds complexity. Every time you add a new cloud service, whether it be public cloud or private cloud for that matter, you're going to be adding an additional layer of complexity, because every single cloud runs a little bit differently, and they each have slightly different tool sets. They run they have slightly different characteristics. Now, many customers we find do like to use multi-cloud, and they have a number of reasons for doing it. One is they want to kind of spread the risk. And they want to put it in multiple clouds for that reason. They also I've also seen them where they say, one cloud does a better job at doing something, and another cloud doesn't do it as well. So they'll also put their applications, map them to specific cloud requirements. Now, what's important with all of this, of course, is the network, because the cloud providers are not particularly motivated to do multi-cloud, private multi-cloud, or at all. So that's where a company like Verizon can be very powerful, in that that we provide that. Excuse me. We provide the capability to connect multi-cloud seamlessly, and the the end users are not aware that the database is sitting in Microsoft Azure, the applications are sitting in AWS, and the front end is Salesforce. That's completely transparent to the end users. But we provide the mechanism to allow that to all happen transparently. But it does require, as Raul noted, does require a higher level of skill sets, because you have to be comfortable with all those different clouds, and you need to, and it's also a much more complex architecture.
Thanks for that, Beth.
I'd love to-
So I love it, because we went with Roku for transformation to you more tactical, the challenge of the hyperscalers in terms of maybe there are certain biases. Last but not least, Raviotti, what do you think? What's multi-cloud mean to you? What are the key challenges?
So, I mean, we start with the fundamental building blocks, right? What are you trying to connect, right? It's the workload types. Like, I want to connect, bare metal, EC2 instances. I want to connect microservices. I potentially move to the cloud for reasons like Matt mentioned, right? I'm decoupling these monoliths into possibly data sources that are cloud native, right? I want to consume a Redshift PaaS service, let's say. Or I want to have just-in-time execution of a Lambda function based on some sort of trigger, right? Networking, as just as a pure play connectivity technology, should enable all this to happen out of the box, right? Security should be an outcome that is not bolt-on, that is rather built into any initiative that you do. Third, it should work across all these major CSPs, and it should not. There should not be an additional encumbrance on the customer saying that, listen, the common semantic layer that you want to use for connectivity and security forces you down let's say, a standard L3 path or an IP path. Guess what? IP is not even relevant for some of the cloud, workloads anymore, because, IP addresses keep changing on the time. So if you're doing your standard sort of networking constructs, standard sort of, policy constructs based on, a layer 3 identity, it's not even going to work, right? As an outcome, you could automate your way through all of this, right? Like customers who are super brave, like Rahul mentioned, want to perhaps, build this, infrastructure themselves. But what we found is, while you are getting your security outcomes, you're getting your connectivity outcomes with an agile sort of DIY approach. Once this automation repository grows beyond a certain size, you start to lose some of that agility, because the governance around all of these structures becomes hard. Am I meeting my cost guardrails, or am I starting to slow my developers down because they can only do certain things, right? Based on the sort of minimum security, hardened template that they can start to use, right? We believe that's where ISVs like Prosimo sort of come in, because we provide that single semantic layer, not just for provisioning your infrastructure with very standard sort of off-the-shelf, connectivity and security constructs, not just for your L3 workloads, not just for your subnets, for your PaaS services, for your applications, for your for your serverless functions, regardless of where they live in the cloud. At the same time, retaining their cloud native nature. I don't want to run everything at the sort of the L3 semantic layer, right? I want to be cloud native to the extent possible, right? Because that's where I'm going to spend most of my money on, and all of this within a cost envelope which basically means once you're doing sort of this full stack connectivity, full stack security, you're also giving them full stack observability constructs, right, around which to manage and govern this infrastructure. So that's how we think about, what an ISV like Prosimo sort of, can bring to value, in this multi-cloud environment.
Thanks for that. And actually, we got into the second topic, and so that this is great, because the second topic I want to get into was how the industry is responding to the challenges. And so you gave a great perspective in terms of Prosimo and ISV is helping to drive common semantics and better observability. Now I want to give the other folks an opportunity to hit on that question, man. And like, how is the industry responding? And let me toss in a wrinkle, because looking on the Q&A, I see that someone's asking, and Beth, I look to you, given that you're coming from Verizon, perhaps network as a service is a buzzword you've heard about recently, right? The composability and the scalable network services. And so the question therein is how is the same question as what Navjoti just answered, is how is the industry responding? And maybe you can answer it from the perspective of comparing and contrasting how you see the industry responding against this buzzword of NAS, right? That is coming into view. So what's your take?
So let me answer. There's sort of two answers. One is, as you may be aware, Verizon launched NAS as a NAS Solutions is the official name of the product, which is primarily it's actually, there's some cloud aspects to it, but it's actually primarily focused on the site, the local sites, because the cloud vendors tend to think very data center centric. I've had some weird conversations with some of them where I've said, yeah, but the customers are using these applications that are hosted in your cloud environment out at the edge, and Raul touched on that a little bit too. And they just kind of look at me blankly. They just don't. It's the concept that the actual users of all of these things are actually outside of their data center and outside of their purview is completely a foreign concept. So we took NAS as we took the concepts of NAS as in, you go in, you order certain things. It's super easy to order. So what we determined was that to turn up an edge site, you need three things. You need some kind of hardware, you need some kind of connectivity, and you need some kind of network software. That's essentially the absolute minimum you need. And traditionally, those have been sold separately. And we said, why should they be sold separately? There's no reason to sell them separately, because absolutely every customer is going to need those three items together to get the site running. So we repackaged it to say, hey, you can buy a site type, and we have 5 site types. You can buy a site type that has these 3 components in it. So in that sense, what we did is we took the concept that the cloud providers have been very, successful with, which is you go onto their website, you put in a credit card, you're up and running. You can start up a VM in, 2 minutes, and you're up and running. So that concept is very powerful to customers. They understand it intuitively. It's the cloud, however, is, what we've done is we've created essentially some automated processes to allow customers to order connections into public clouds. And there's no magic to it. There's got to be a router in place. We call it an NNI, which is a network to network interface. So it's an interface between our network and the cloud provider's network. And it can either sit inside a data center, or it can, they always sit inside a data center, actually. I take that back. And the idea is that these can be turned up very quickly and turned up so customers can turn them on. I mean, Secure Cloud Interconnect can literally be turned up in 15 minutes. That is network as a service, truly network as a service, right? Customer orders it. They actually can go onto our onto our Verizon Enterprise Center. There's an order button. They go in, pick which area they want to connect to, what cloud provider. Bing bang, it's set up, and then they So we ask them for some very specific questions, and this relates to somebody's question about VCP. We need to know when we connect Secure Cloud Air Connect, we actually need to know what the customer's VCP is, because otherwise we would, that's how we make that connection. It's completely private. So we are connecting. That connection goes from the customer's private network directly into their VCP, which is also private within the cloud environment. And we have a number of ways we can do that. But the point is it's highly automated and very simple to understand. And so we've taken a whole lot of very complex networking and kind of gotten it down to, hey, give us these two pieces of information, your account number and your VCP, and we'll do the rest.
Well, thanks for that color. In terms of what if I summarize correctly, it's NAS is very complementary to the discussion that we're discussing of networking inside the cloud, right? And with efforts like Verizon, it sounds like making it that consumption model that much more fluid and scalable, no differently than I think we've come to love and learn, and use in the cloud space. So, Rahul, same question in terms of if we look at how the industry is responding to the challenges, from your perspective, is the industry responding, or is the industry still trying to figure out, how do we attack this? Because you painted a picture where there's any number of points that you can come in at this, and any of those can have thorny problems associated with them, right?
So great question. I'm gonna answer it very transparently, in the sense there are challenges, there are followers, and then there are people who are still waiting. But I'm very sure cloud and as a strategy is in every CEO's playbook, and there's no way around it. Especially with network as a service and dynamic requirements, as powerful the user devices are becoming, the expectation, like Beth was saying, of the seamless and the real-time availability of the applications and services is going higher. And that's what public clouds are able to do. What they have done is they have abstracted the complexity. You go to the marketplace, as Beth was explaining, you put down, maybe upload your Helm chart or an application manifest, and other things will just happen in the background. Maybe a process engine just starts and see this is the compute which the manifest is telling the CPU resources, the infrastructure requirements, the IP requirements, and whatnot. In the other part of the industry, what I think, and then Beth was alluding to that if we have to think about network as a service, what underneath we are trying to do is 4 or 5 things. You have templates. They might be, like Beth was saying, there are 5 different templates for them. For every application, there'll be multiple templates, or for different edges, there could be multiple templates, small, medium, large, or some sorts. Under the templates, what we are trying to tell them is what is the resiliency factor, what is the scale of the, let's say, the infrastructure booked for the application, what are the configurations around it. Configuration goes from everything from the requirement on resources, security, monitoring, policies around lifecycle, when to scale out, when to scale in, when to raise an alert, when to raise a severity alert, what are the security groups, access profiles, and whatnot. And the systems which are coming through from the hardware to hypervisor to application services being integrated all through the APIs, which are abstracted all from customers. So customer sees that this is my application, this is my requirement, just make it run. Run it in a data center, as you were saying, or run it at the edge, or run it on the bare metal. And that's why I think some of the players in the industry, the SaaS players, are able to do it much more faster. Doesn't matter if they're using their private cloud or they're using public cloud, but they are able to abstract the complexity and give the quality of service and experience to the customers. Then there are industry players who are leveraging hybrid cloud. There are industry players who are just going public, like Jyoti was also highlighting that when the customer comes to them, they understand the requirement and they suggest the best cloud policies and the profile and monitoring aspects and lifecycle around it. So yes, industry is looking at it. Everyone is jumping on it. There are people who still think It is more complex. Yes, cloud is complex. There's no way around it. But once you get the hook on it, you understand how to manage it. Start small, router, control plane, maybe AI application, maybe even SaaS applications. Understand as an organization what skills you need to gather and what skills you need to build on, and what are your success criteria? Is it cost? Is it resiliency? Is it time to market? Is it network as a service? And if you are able to put all these pieces matrices together, you'll get the answer. And the general trend says that yes, everyone is looking into it. There might be different conversation to say, yeah, public is better, hybrid is better, or private is better, but yes, everyone has this on their key agendas and life cycle.
Thanks for that. I've been in the industry now over 20 years, and it harkens back to anytime there's a technology or process inflection. The first thing people should do, and I think you painted it quite clearly, is take an assessment of where you're at, right? Before you jump into the deep end of the pool, because I think we've all have seen the horror stories about people who say, let's do cloud, and just jump in without thinking about what that really should mean to them. and then all of a sudden figure out, wow, this is more complicated. This is more costly. Let's go back to on-prem. Let's bring back all those applications and the burn, the cloud burn that thing we've heard. But I think that's a common theme I hear in the conversation today. That again, there's a common thread that I've heard over the several decades that I've been in the industry. In this last 10 minutes for the last topic. Now, we haven't heard from you, Navjoti, and I wanted to pose a question in terms of, Rahul talked a little bit about where the enterprise should start, but let's take it now, distill it down a little bit more, and given that you're coming from the vendor side, we'd like to get your perspective in terms of what should an enterprise look for in a multi-cloud solution, and so what's your take?
So let me just write off what what Rahul was mentioning earlier, right? A, assessment. B, what are your success criteria, right? And if I was the CIO, I would give you a very short answer, right? All of the above, right? I want best in class security, I want best in class connectivity, cloud native, and I want all of this, something that fits my wallet, right? Now, if you sort of double click on these business outcomes, right, which are essentially what something like a NAS solution provides, right? Now, if we break that down into two parts, there is to the cloud access problems and, the user to app, if you will, or, improving the experience for end users. And there's within the cloud, right? I think there was another question on the panel, which was talking about the sort of the SD-WAN construct. So, NAS as an offering that, probably brings these the access to the cloud workloads, and then there is another piece of the NAS puzzle, right, which is really connecting workloads inside these complex and diverse sort of workload environments. Now, when I look at the outcomes, it's really agility. Matt wants agility, he wants scalability, he wants reliability, he wants to understand the cost envelope, right, which in turn means, hey, I have to have sort of full stack observability. What is the NAS giving me? NAS is giving me the ability to be cloud native. It's giving me the ability to spin up these constructs, spin up the plumbing, make sure they are secure, the entire stack, not just things at the L3 layer, right? Just the entire stack in a matter of minutes, right? And give me best in class sort of constructs, best in class paths, right? For instances that are talking perhaps across two clouds, maybe consuming a service from the other cloud, don't just pivot me always to the public internet, right? That's the default choice. If I have a backbone that's running through Verizon, allow me to use it, right? If I have a backbone that is perhaps going through some of the DXER connections across a colo site, let's say an Equinix or a Megaport, give me that option. If I want to go across two regions in the cloud, right? Give me that connectivity option in addition to sort of the cloud backbone, right? So that's sort of within the cloud. And don't just sort of pivot me to, a L3 native model. if I want to use or I have problems, right, in the multi-cloud infrastructure, things like overlapping IP addresses by virtue of sort of M&A or some construct like that, right? Cloud native providers have done a great job. Hey, use a private link, use a private service connect. Guess what? Limited to their cloud, possibly limited to a region. That's where ISVs like us come in, saying, hey, how do we make this multi-cloud? How do we make this sort of cloud native connectivity model available in a multi-cloud environment, right? So if that's what you want to consume, at an application layer, you have that choice. Now, is this riding off the cloud backbone? Is this riding off the public internet? Is this riding off Verizon's MPLS circuit? Is this going through an Equinix colo? You have that option. Is this secure end to end, not just at the L3 layer, but all the way up to WAF, right? Like Matt was mentioning, right? Do you have that service, or am I doing infrastructure Jenga, like putting in blocks of appliances just to get outcomes at different security layers along all of these, right? So I would ask these questions because you do your assessment, licenses, infrastructure, connectivity constructs. Say, here's what I'm going to pay to run this infrastructure. Then there is a cost to sort of operate the infrastructure. Metrics like MTTR, metrics like change frequency, metrics like change failure rate that Matt was talking about. How do I hit my numbers? And metrics of all of those constructs, right? Because guess what? If you're spending X on sort of deploying the infrastructure, you're possibly spending 3x on operationalizing it, sort of in terms of the operational cost. People are a big part of that. While we would all want, a Terraform layer or possibly an LLM layer, that is directly able to take intent and translate that into cloud native constructs, something we are thinking of, by the way. But automation can only solve sort of part of the problem, right? The skill gap is very real. It's across this multi-cloud environment, right? It's a big part where you end up with these siloed organizations where you have GCP experts, you have AWS experts, you have Azure experts, and you need this single semantic layer. I keep going back to that, right? You need this universal language. The teams across can sort of communicate with each other, saying, this is what security means. This is what a segment means in the multi-cloud environment. And it's going to mean the same thing in AWS. It's going to mean the same thing in GCP. It's going to mean the same thing in Azure, right? If I want private link, it's going to mean the same thing across, all of these different constructs. If I want cross-cloud connect, I have these options across all the clouds, right? All of this with full stack observability and a cost envelope that, you can meet. So you get all of the NAS outcomes, right? Which is, really agility, cost, governance, and compliance. You get all of those things, but without the operational overhead. I don't necessarily want to maintain sort of this Jenga of, appliances, if you will, right? So, yeah.
I love that analogy,
That's
the Jenga of appliances or infrastructure. Hopefully, no one in the audience is necessarily finds it that, but unfortunately, I'm sure that some out there are facing that picture on a day-to-day basis. Well then, we're getting here to the end. We've got about 5 minutes. I want to close it and give the opportunity to provide each of you a couple minutes to provide closing comments, and you can revisit one of the questions or discussion threads. And we'll start with you, Beth. That perhaps you want to talk about a little bit about what the enterprise should look in a multi-cloud solution, or circle back and just your thoughts about today's conversation. So again, let's start with you, Beth, and then we'll move on to the rest of the panelists. So take it away.
I actually want to touch on some of the questions that were asked because I think we did. There was some very important questions. One of them: nobody goes to multi-cloud to save money. Just forget that. It just put it out of your head. Nobody moves to the cloud to save money either. However, you get a lot of flexibility. You get agility. You get a whole lot of goodness. But if you're going to move to the cloud to save money, that's just not going to happen for you. The other question I'd like to touch on is somebody wrote in a question about SD-WAN. SD-WAN, not to knock it, we sell a lot of it. It's not a panacea. It's, at the end of the day, it's just a VPN overlay with a cloud controller plane. And I know a lot of people think, oh, it's so much more, but that's all it really is. And Not that that's a bad thing. It is, but it's not going to solve cloud connectivity directly, and certainly not going to solve multi-cloud. What we find is many of our customers use SD-WAN, and they actually may or may not use it inside their multi-cloud environments, because the only way to do it is as an SD-WAN native architecture is to put in a SD-WAN node in each one of those cloud environments. So it depends upon how many environments. If you have 5, that's probably okay. If you have 30 or 40 or 50, it can really rack up. So we do have customers that take sort of a different approach to it and do an offload to, so they'll have an SD-WAN network, and then they do an offload to their cloud environments. It may or may not be private MPLS. So that's your answer. It's not the panacea.
Yeah, if anyone thought that they're going to save money, unfortunately, it's got a little rain on their party. Rahul, 30 seconds. What's your closing thoughts about today's conversation on the main topics?
I think we touched upon a lot of good topics. I think the last thing which I would like to my quota second is look into the ecosystem and partnerships when you're selecting the multi-cloud, because I think the multi-cloud comes into picture when you and an organization kind of believe that you understand natives of cloud and you're not able to get the best out of one of the clouds. It could be having availability zones, could be having a certain application which comes natively with that flavor of cloud. For example, Microsoft buying Affirmed. If you have Affirmed in your network, probably Affirmed on Azure would work best because that's their native organization. AWS working with Dish for the Open RAN. Probably that's one thing if you are trying to do Open RAN, and if you want to go with a hybrid or a public cloud provider, then probably AWS, right? So look into those kind of aspects as well. Like Beth said, you're not going to save cost, but you can probably have other parts of things like agility, culture, DevOps, and even reduce the number of operation people required if you find the right partners and you have grown in the skills. But look into the multi-cloud strategy when you have probably achieved the phase 1 of your organization setup, cultural setup, understanding of your application stack. Because trust me, everyone is in there for certain business, right? And going into cloud, going into multi-cloud, you probably have your, as we were discussing, success criteria. Pretty straightforward that we want to be in an organization X. We want to have, let's say, releases every month. We want to be more secure. We want to be always available. We want to be having minimum latency for our customers when they're accessing these kind of apps. We want to be AI native. So have those definitions, pick up the right application stack, and then the combination of multi-cloud based on the applications ecosystems.
Very good, very good. Well, unfortunately, I see that I'm getting the hook. This is a live event, and I'll be respectful of our audience's time. But this conversation can continue on for hours, right? And this is just the tip of the iceberg that we covered. So I appreciate my panel conversation today. Hopefully the audience found it insightful. I definitely found it insightful. And hopefully we'll run across each other here on the path of the cloud journey. And until next time, thank you, everyone.
Thanks so much, Mauricio. That was a great panel. And now I'm handing it over to Kevin for his keynote.
Hi, I'm Kevin Cochran, and I'm the Chief Marketing Officer here at VULTR. VULTR is the world's largest privately held cloud infrastructure provider specializing in cloud GPU. And I'm excited to speak with you all today around generative AI and the new multi-cloud imperative, composable infrastructure. Before we begin talking about composable infrastructure, I wanted to take you back in time for lessons learned from the past as we embark on a new era of cloud compute. Our journey begins in 2000, when organizations started to go mainstream with their first web application architectures and started to build out all of the build, test, and production deployment environments globally in order to build a new generation of web applications. If we roll the clock forward 10 years, we started to see mainstream adoption of cloud infrastructure for new cloud native application architectures where people were leveraging low cost at the time cloud compute in order to distribute production workloads across a global workforce and global consumer community. Now we are at the dawn of a new era of cloud compute, where GPUs are at the core of accelerating new types of workloads, specifically to advance new AI and ML initiatives. And in this new era of cloud compute, one of the lessons learned from the past is how do we avoid what has become known as the trillion-dollar paradox. With cloud infrastructure, the promise was to quickly hyperscale our business. But one of the things that has been learned is that we increasingly realized a hyperscaling of cost and complexity. This trillion-dollar paradox meant, simply put, that the cost of cloud operations almost precluded successful scaling profitably of our businesses. In one of the most egregious examples, we saw the case of Dropbox, which started the process of repatriating their workloads to their own co-location facilities, and in so doing had dramatic cost savings of $75 million over 2 years and a market increase in margins. The promise of the cloud was always to provide the lowest cost way to very quickly scale our production workloads. But increasingly, what we saw in the past 10 years, a consolidation of cloud infrastructure providers, meant that we wound up being overbilled, overcharged, and having overly complex infrastructure that locked us in. Again, we're in a new era of cloud infrastructure and embarking on a new digital frontier with massive innovation in the underlying GPU infrastructure that is unleashing a wave of innovation in new large language models and other supporting infrastructure to truly make AI and ML the promise of the future. And currently today, in this mad rush to unlock the benefits of AI ML, companies are looking to move very, very fast, specifically to get access to the latest generation NVIDIA GPUs for their production workloads. And what many organizations have found is that procuring and deploying and configuring those GPUs in their data centers was simply not fast enough. The time it takes to both source and provision GPUs and make them ready for use for ML engineering teams simply meant that time to market was too long. What this has driven is a massive urgency to accelerate AI ML by leveraging a cloud GPU model. Simply put, this takes out all of the complexity and the time delays for configuring and provisioning in your own data centers and relying on cloud vendors in order to quickly spin up your GPUs. But one thing we've also learned is that this process alone is simply not fast enough. The complexity of the GPUs is not only in securing and provisioning them, but it's also configuring them to make them make productive use of your workforce. Simply put, ML engineers are not systems administrators, and making sure that the GPUs are ready for people to begin immediate productive use by configuring all of the drivers and all of the necessary supporting infrastructure is a key requirement. Greater complexity in the pace of innovation in GPUs and pace of innovation in the supporting drivers and software infrastructure means a faster time to market model is needed. To move fast, we have to take away the systems administration pain. We truly need on-demand cloud GPUs that are pre-configured for instant on, so ML engineers can immediately spin up their Jupyter notebooks and begin working with the latest and greatest models and begin fine-tuning and pushing to production inference all of their tuned models to support all of their new AI ML initiatives. If the process takes longer than 20 seconds, it's simply not fast enough. Beyond the core requirement for training, however, is a bigger and broader requirement. Again, a lesson learned from earlier epochs of web infrastructure. We need to think beyond just the training clusters we're spinning up, but we also need to think about how we can actually fine-tune those models on localized data sets in region, and then also push those tuned models to production inference as close to the edge as possible, ideally co-resident with our cloud-native application code, so that people that are accessing our new services on their mobile phones or on their desktop have the best performance and the greatest responsiveness, and also delivered at the lowest cost with no latency and no round tripping to backend servers, oftentimes on another continent. We need to have a truly global architecture and a true life cycle for managing the spinning up of GPUs instant on for productive use by our ML engineers that can also be pushed to regional clusters for tuning and ultimately to a worldwide global network of inference servers to support your employees and your customers wherever they live and work. And in so doing, we need to also make certain that we avoid the next trillion-dollar paradox. And that trillion-dollar paradox is a potential consequence of what we're seeing with possible consolidation of core AI infrastructure, once again, in the big three hyperscalers. Simply put, the cost of leveraging the pre-built models from the hyperscalers may wind up leading to a significant hyperscaling of costs that lead us right back to the same problem we saw with core cloud compute, where we had escalating costs and complexity that ultimately left us with the trillion-dollar paradox and a decision point on how we optimize our workloads and which workloads we deploy in the cloud versus which workloads we repatriate to our local data center. Simply put, the cost of these pre-built services and the ever-growing complexity and interdependencies between them face a risk to the ongoing scaling profitably of our business models. So the countervailing force is the massive innovation coming out in the open source community. The whole goal here is to move away from thinking about an all-in-one LLM model that will ultimately lead to the same lock-in that we found in the earlier era of cloud compute. The all-in-one LLMs can lead to an exorbitantly high cost of production inference with significant security, privacy, and compliance risks for training on your own data sets. Oftentimes, these generalized models can also have higher rates of hallucination and random bias. And obviously, as an all-in-one model that's just limited to some third party that you're contracting with, means that you don't have as high a degree of control in terms of adhering to NIST standards around explainability, meaningfulness, accuracy, and knowledge limits. Within the open source community, however, we're seeing an explosion of innovation of purpose-built LLMs that can give you freedom and flexibility. Their compact size leads to faster response rates, lower costs, enable domain-specific tuning, and allow you to tap into rapid evolution to control your own destiny, and most importantly, avoid lock-in. What we believe here at VULTR is that to truly accelerate AI ML and to achieve a new era of cloud compute, a GPU accelerated era of cloud compute, we need to move to a fully composable model where all cloud services are modular, atomic, orchestratable. And the most important thing is eliminate any and all dependencies so that you don't become locked in, like in earlier eras of cloud compute, to a singular provider, and not just get locked into the core infrastructure, but locked into all of the pre-built AI services that essentially wall you in. So what we believe very strongly is that to move fast, not only now, but to move fast in the future, we truly need to unlock the benefits of multi-cloud and actually move to a fully composable cloud GPU model that locks in the benefits of open source innovation, locks in the true benefits of multi-cloud, delivers true infrastructure as a code, and again, eliminates any and all cost and complexity for consolidating cloud infrastructure and AI ML service providers. What we believe pretty strongly is that we need to have a new global GPU architecture where you can instantly spin up your core training clusters on demand with instant and ready access for all of your ML engineers to begin productive work. And then most importantly, also be able to tap into all of the purpose-built open source LLMs through a public registry so that you actually have the lowest cost, fastest way to get time to market and control your own destiny. Moreover, we believe that the entire application lifecycle needs to be orchestrated so that those trained models can then be immediately published and made available in local regions to be tuned against local data sets. And then again, to be immediately published and made available to different instances of specialized GPUs optimized for inference as close to the edge as possible. A little bit about VULTR is we believe very strongly in pioneering this new epoch of GPU accelerated cloud, leveraging the best of open source innovation and unlocking the true potential of AI ML and all of the new LLMs that are coming to market, and putting in place a composable infrastructure that enables you to spin up and spin down on demand at the lowest possible cost with zero complexity and zero lock-in, all of the instances needed for training, for tuning in region against localized data sets, and for pushing your fine-tuned models out as close to the edge as possible across 32 regions and all 6 continents to drive production inference without the incredible exorbitant cost of pre-built models from the big 3 hyperscalers. So with that, I'd like to say thank you so much for your time today, and I look forward to discussing more about a GPU accelerated cloud with you in the future.
Thanks so much, Kevin, for that great keynote. And now I'm handing it over to our final keynote for the session, Patrick from Vodafone. Over to you, Patrick.
Hi, it's a pleasure to participate in the Multi-Cloud Summit. My name is Patrick McCardle, and I'd like to talk to you about the state of the multi-cloud industry. To start, just a little bit about my background. I've been in the telecom and IT industry for more than 40 years, about 33 years with AT&T and nearly 10 years with Vodafone, the UK-based telco. Now, almost all of my career has been spent working with AT&T and Vodafone's largest enterprise customers, the market that would be most likely to use multi-cloud. So as we get into the multi-cloud discussion, let's talk just in general about cloud services. We all know the term, in air quotes, the cloud, has been around for a long time, going back to ARPANET, probably, if not longer. And back then, it generally referred to a system that was accessed remotely via a telecom circuit or the internet, or ARPANET back then. And in network diagrams of the time, a cloud was used to describe these systems, because from an application and computing point of view, it didn't really matter where they were physically located. But time marched on, and the world of computing and cloud computing became more interesting, and virtualization and the benefits of the scalability benefits of virtualization came to be synonymous with the cloud. Whether we were talking about VMs on an IBM mainframe back in the 70s, or VMware in the late 90s and when it started up, or early 2000s. So now in modern times, cloud computing to give a definition, is a system that provides services on demand. It uses a consumption-based commercial model, and meaning you only pay for what you use, and the customer provides the administration themselves, meaning self-service. There's plenty of other definitions that include lots of other capabilities, but I think they all include those 3 points at a minimum. Now, let's keep in mind that SaaS applications, while they are in the cloud, they are one of the many iterations of cloud computing. Some examples are Salesforce, ServiceNow, Workday, Zoom, which you might be on right now, Teams. And although SaaS is immensely popular, and yes, enterprises often use multiple SaaS services, let's put that aside for the purposes of this discussion about multi-cloud. So given that, let's talk about some of the some of the cloud deployment models. There's 3 basic models. There's public, there's private, and there's hybrid. So a private cloud model is dedicated to a single enterprise or single organization. It could be in a data center that they own, which would be on-premise private cloud, or it could be in a data center owned by a third party, where it would be a hosted private cloud. Then there's a public cloud. A public cloud is based on a shared infrastructure, and this is usually provided by a third party, like the famous ones, Azure, AWS, Google Cloud Platform, GCP, et cetera, et cetera. These are accessed over the internet, and they're available to anybody who wants to buy them. And then a hybrid cloud is a combination of those, and but still generally using a single cloud provider, and it's designed for interoperability amongst workloads and data portability. Now, while those 3 models assume a single cloud provider, multi-cloud refers to a model using more than one cloud service provider at the same time. So a multi-cloud model enables that environment. That could be public, it could be private, it could be a combination, but it's using different CSPs. Now, there's many opinions, but in my opinion, the advantage of a multi-cloud approach is to give you flexibility to operate with the best computing environment for each particular workload. So to elaborate on there was a paper written by Lee Atchison describing a multi-cloud model called polycloud, where because providers have differentiated themselves with particular capabilities or specialities, polycloud is a best of breed multi-cloud model, and it takes advantage of the cloud service provider's particular competitive advantages. So for example, and hypothetically, AWS may be the leader for compute, and Google may be the leader for AI, and Azure leads with enterprises that run a lot of Microsoft applications. So enterprises might choose the CSP per their particular expertise, per the CSP's particular expertise. And I agree with this concept. But for the ease of this discussion, let's treat multi-cloud and polycloud as synonymous. So as I said, multi-cloud enables enterprises to use the best cloud for each workload in order to meet the requirements for those applications and to take advantage of different providers' capabilities. Now, Vodafone, for example, uses a multi-cloud model for that reason. We are a CSP, and we still use 5 other cloud providers, just that I'm aware of. And although Vodafone is a complex global operation, it isn't unique, and I venture that a lot of enterprises follow a similar approach. So there are many surveys regarding the popularity of cloud services, and many enterprises are not using any cloud services at all, irregardless of the hype and the hyperbole around cloud services. But still, cloud is gaining share. There's no doubt about it. And many enterprises that are using the cloud are using 2 or more or 3 or more cloud service providers. And there's many reasons why they're adopting multi-cloud. And here are some of them. And this is according to a recent IBM Turbonomics survey. So one of the reasons that respondents mentioned was to leverage different services like artificial intelligence and machine learning, big data analytics, edge computing, 5G, IoT, all the techno buzzwords, and choosing the combination of clouds that best support those solutions. For example, the data warehouse provider isn't necessarily the best or the most cost-effective provider for the big analytics, the big data analytics functions. So that could be a reason to split those functions across 2 different cloud providers. Another reason that was mentioned is to guarantee availability. Using multiple cloud providers can help organization increase the operational resiliency by spreading the risk of downtime across multiple clouds. And the fan favorite is to minimize the cost by choosing the providers that are the most cost-effective for those specific workloads. So what's driving the cloud market? What's driving the multi-cloud market? Applications operate across different parts of an infrastructure. Corporate IT can use a mix of technology stacks for the front end and the back end. And each of these may have different technical or commercial requirements, driving the enterprise to choose the cloud that best suits those specific needs. So organizations can realize benefits from a multi-cloud approach. For example, I've talked about best of breed. To elaborate on that, AI is all about data. And a lot of customers' data is in their, for example, is in their Oracle database estate. So a multi-cloud model enables a customer to use the AI engine of the choice, just to use an example, Google, and apply it to their proprietary data. And again, for example, in their Oracle data warehouse, running on OCI, Oracle Cloud Infrastructure. Now, another reason or another benefit is to limit network latency. Customers say that better application performance and very low latency from the database to the application front end is critical. And in the past, this added latency or this latency has blocked them or has blocked some customers from being able to leverage any cloud. So to meet this, Azure and Oracle have added an iteration to multi-cloud called Oracle Database at Azure. And in this case, Oracle has physically deployed in Azure data centers, reducing the latency between those 2 clouds from milliseconds to microseconds. Some other reasons are compliance and governance. For example, around data sovereignty. The personal data of EU residents must remain in the EU. And this drives enterprises to use clouds located in Europe. And these might differ from the clouds that they use elsewhere. So by default, they're driven to a multi-cloud model. One other topic that's raised frequently in surveys is to prevent vendor lock-in, to mitigate the risk that a cloud provider might suffer from a supply chain disruption, or increase the prices, or reduce the support, or retire the products. And anecdotally, some customers have even mentioned to me that they've got an interest in maintaining skills in various clouds to ensure flexibility in the future. Now, I'll add that in my experience, the supplier does have an interest, maybe not so much locking in a customer, but to become the sole provider to that customer for whatever the particular technology might be. And it isn't all bad. They may offer commercial incentives to gain this position with the customer. They may deepen the support and overall provide more of a consultative service in a situation like this. But this concept has been around since the beginning of commerce. So I'm not saying that this isn't a concern or it isn't valid, but it isn't unique to cloud computing, at least in my opinion. And then another topic is internal autonomy isn't a benefit, but multi-cloud is a side effect, or can be a side effect, of internal autonomy, where internal organizations choose the cloud that best suits their requirements, their technical specs, their budget. And to use Vodafone as another example, we have 17 operating companies, and it's just not realistic to expect that there's a unanimous decision over which single cloud provider to use. So in the same Turbonomics survey, some customers mentioned a hesitancy to go to the cloud or to use multi-cloud. And here's some of their reasons. And that's that even with the available tools, portability of applications and data is still a concern. Ensuring security across the multiple platforms is a concern. Managing workloads, managing compliance, and the lack of visibility of application performance across multiple clouds are some of the concerns that were mentioned. Now, as the multi-cloud market continues to grow, the market to solve the problems that I just mentioned is also growing. To address these challenges, many suppliers have introduced multi-cloud management platforms and tools that provides centralized management, governance, visibility, and operational capabilities across the multi-cloud landscape. For example, some other examples are Vodafone Business Multi-Cloud Platform, Dell Apex, and VMware Cloud Management are some examples of these platforms, and there's many, many others. So as use cases for multi-cloud continue to multiply, to overcome the barriers that customers have mentioned, the barriers to multi-cloud management platforms are continuing to proliferate. And organizations are either developing applications in a cloud-first approach, or they're migrating existing services to the cloud in a lift and shift approach. So then studies show that as successful deployments of some services in a cloud or any cloud lead to more successful deployments. But IT managers understand that the cloud is a means to an end. It's not a destination. So even though multi-cloud may be more complicated, providing the greatest value to the business is their purpose. And because it offers organizations greater flexibility and enables them to choose the best services and the best pricing models to meet their business objectives, the continued growth of the multi-cloud market, in my opinion, is inevitable. So I thank you for your attention, and please enjoy the rest of the Multi-Cloud Summit.
Thank you so much, Patrick, for that excellent keynote. Listeners, you can join us back here at 12:45 p.m. Eastern for our next session. But before you go take a break, don't forget you can fill out our post-event survey, which will show up in your inbox at the end of today's event. Be sure to give us any feedback so that we can plan for our future events. Also, you can register now for Silver Linings Cloud Executive Summit in December in Sonoma, California, from December 6th to 7th. And we've got a special discount code for you. All you listeners, you can use Silver Linings as the discount code to save $500 off your pass. So be sure to register today. I will be there in Sonoma, so I hope to see you there. And with that, we're going to take a little break, and we'll see you back here at 12:45 p.m. Eastern for session 2.